In this video, we will be looking at analysis of quadratic functions and looking at their graphs and how we can think about the axis of symmetry, maximum or minimum values, and then use some of the information we learned in the last video for looking at the quadratic formula to guide our thinking. When we have a graph or a function that's raised to the second power, its picture will be called a parabola or its graph. The point where the parabola changes from decreasing to increasing, like in the first example, decreasing and then switches to increasing, or increasing to decreasing as in the third picture. That point is called the vertex. We would call it a minimum point in the first and the second case, and we would call it a maximum in the third case. We use the letters H and K to denote the x and the y coordinate of the vertex. And when we think about that first coordinate, there's a line, x equals h, that cuts through the center of the parabola, and we call that the axis of symmetry. One thing that you'll notice is that the two x-intercepts or zeros are going to be halfway between that axis of symmetry. Another thing to notice is that in this first example, if I look at this version of the function, it's in a graph transformation format, and it sort of ties in with an example we were doing at the end of the last video where we were looking for the maximum height of a ball that was being thrown. And we said that the x-coordinate was going to come from here, and that had to do with the graph transformation of the graph being shifted to the left. I can see that shows up here as a -3 in the vertex. And then also this right here shifts the whole graph down, and then ends up showing up as the y-coordinate in the vertex. So again, the vertex comes from these two pieces of the graph transformation, and so we call those variables, in this case, this one is h, and this one is k. Another way to think of where the vertex of a parabola is to consider that the x-coordinate comes from -b over 2a, and that comes from a part of the quadratic formula. And then if I find the x-coordinate there, then I can plug that particular number into the function to get its corresponding y value. We'll do some examples to show you. Here's an example of a quadratic. We know that this function is going to be facing down, and we know that because there's a negative sign in front, right? We want to find the vertex, the axis of symmetry, and then a maximum or minimum point. So we can just get kind of a rough graph. Let's start by finding the axis of symmetry. The axis of symmetry will occur at x equals -b over 2a. So I'm going to find a, b, and c in that original. A is -3, b is 6, and c is -2. And I'll plug a and b into this equation here. I'll have a -6 over 2 times -3. Simplifying this, I get 1. So in this particular case, if I'm thinking about what my graph looks like, I know that when x is equal to 1, that's where this line of symmetry is going to be. It's going to be where the middle of the graph is occurring. The maximum or minimum point, maximum in this case because the parabola is facing down, right, is going to be somewhere on that line, but I'm not sure where it occurs. So what I do is I take that value I just found, 1, and I plug it back into the original equation. So I'm going to look at f of 1. That gives me a -3 plus 6 minus 2, which is also 1. So that tells me that the vertex is going to be at the point 1, 1. I don't know what the zeros are in this case, and that's okay. For now, we're just trying to get a rough sketch of the graph. So we know that our graph is going to look something like this, right? Approximately. So we found the vertex right here. The axis of symmetry we found is the equation x equals 1. It's that line that's cutting through the center of the graph. And we can see that the range, the y values that are associated with this picture are anything going from -infinity up to that maximum point, and the maximum point is going to be the y value. The highest point we get to on that graph is 1, and the 1 is included because the graph actually does touch that point. Now, the last question is asking us, where is the graph increasing and decreasing? What are the ranges or intervals where it's increasing and decreasing? And again, we talked about the fact that when we think about increasing and decreasing, we don't include the point, in this case the maximum point, where it changes from increasing to decreasing. So for this graph, it will be increasing from -infinity to 1, and I'm meaning that the graph is increasing all the way until we get to here, and then it will switch to be decreasing from 1 to +infinity. And I'm looking at the graph going down from here. Now all three of these things that I've written look like they kind of look the same. They're all written in interval notation. But remember that these are related to y values. And these are both related to x values. Because the increasing and decreasing has to do with where we are on the x-axis when we are in these two spaces of what's happening with the graph. Here's a picture of the graph over here. And we can see this kind of matches up with what we were just seeing. All right, let's do a different example like that. Symmetry. We'll look at x equals -b over 2 times a. b is -20 in this case, so that'll change to a +20. And when we plug in a, it looks like we're getting 5 for our x value. So if we were to get a rough sketch of a graph, we know that the center of our graph is going to be here at x equals 5. It's that line x equals 5, right? It's actually the equation of a line. We don't know how high or low the maximum or minimum is on this. Looking at the first term here, because this is a positive number, that means the parabola is going to be facing up. So we're looking for a minimum point. To find where that minimum point occurs on the axis of symmetry, we take the value 5 and we plug it into the original equation. When you plug in an x value to find its corresponding y value, you're figuring out how high on the graph or how to go on the y-axis for the graphing part. All right, plug this into a calculator. Oops, I need to put a 5 there. I'm getting 7. So that means that the vertex minimum at this point is at 5, 7. And so our graph is going to be facing up from here somewhere, right? The range for this graph is going to be, I think I've got a graph over here. Yeah, there's our graph from Desmos. The range is going to be from the lowest point in the graph going all the way up. So the range for this graph is going to be from 7 up to infinity. And we include the 0.7 because it's on the graph. These relate to the y values. The other thing that we wanted to know is where the graph is increasing and decreasing. Here, the graph is decreasing until we get to where x is equal to 5. Again, what we're looking at is what are the values on the x-axis where the graph is decreasing, and that's going to go from negative infinity to 5. We don't include the 5 because at that particular vertex, the max or the min, the function is neither decreasing nor increasing. And then increasing is going to go on the other side from 5 to positive infinity. These are relating to the x values. Okay, here is an application problem that we have. The effectiveness of a television commercial depends on how many times a viewer watches it. After some experiments, an advertising agency found that its effectiveness, E, is measured on a scale from 0 to 10. And then they have this formula where N is the number of times that a viewer watches a television commercial. We want to figure out how many times someone has to watch a commercial for it to have maximum effectiveness. So since their scale is going from 0 to 10, we want the effectiveness here to be 10. So we'll plug that in to the equation on that side. So we'll write 10 equals 2/3 n squared, or no, n, minus 1 over 90 n squared. I definitely don't like all these fractions. So right off the bat, I think what I'm going to do is multiply everything by 90 so I can clear all of these fractions. 90 times 10 will give me 900. 2/3 times 90, 60. And then minus n squared. This is a nice little quadratic. I'm going to move the items on the right-hand side over to the left. So we'll have n squared minus 60n plus 900 equals 0. So we're trying to find the maximum effectiveness, and the maximum is going to occur on that axis of symmetry. So the maximum occurs at n, the number of times watched, equals negative b over 2 times a. So b is 60, negative 60. It'll change to positive 60. A is 1, 2 times 1. So it looks like we're getting 30. N is the number of times that someone needs to watch a commercial. We're getting that someone needs to watch a commercial 30 times for it to have maximum effectiveness. That's kind of funny because I've watched some commercials many more times than 30, and it doesn't make me want to buy their product. I just think they're funny or maybe annoying. All right, thank you for watching, and I will see you in class.